So on this one, we've got an original expression and we want to simplify it. Okay, well, how are we going to simplify it? Well, here's the deal. You might think that you can come on in here and you can go like, well, 2 goes into 10 5 times, but that's actually illegal. It's against the math laws. You can't do that. You cannot cancel out things that are added and subtracted like that. You can only cancel out things multiplied. And you might think, well, yeah, but that 2 is multiplied. Yeah, but it's also subtracted. So I cannot cancel 2 into 5. Now, you might think, well, that's weird. Why? Well, really, it's just simply true. Let me show you. Let me give you a little simple example. What if I had like, let's say, 8 minus 2 over 2. Now, really, right over here, really, let me put really, that is 6 over 2, which is 3, right? That's really what it is, right? Because 8 minus 2 is really 6 over 2 is 3. Okay, now let's go back. What if I canceled the 2's? Now it's 8, wrong, then that's wrong. See how that little number example proves that you can't do that. Numbers that are subtracted or adding would be the same problem. Adding or subtracting, you cannot cancel out numbers added or subtracted. You see that? What if it was adding? What if it was 8 plus 2, 8 plus 2? Well, then it's going to be the same problem, except now it's going to be, well, what really is 8 plus 2 over 2? It's really 10 over 2, right? And that's really 5. It's really 5 now. It's still not 8. See how it's still wrong to cancel these 2's. Now you think, well, is it the adding and subtracting? Yeah, it is. I mean, let me go back to what if it was times? Would it be okay? Well, it would be. The answer is yes, it's okay. Let me prove it. What is it really? What is it really? It's really 16, right? 8 times 2 is really 16 over 2. And what is 16 divided by 2? It's 8. So is it okay to cancel the 2's? Yes, it's okay. See how canceling the 2's led to the correct answer when they're times? All right, so do you see what I'm talking about? Now I think, well, yeah, but these are x's. Well, x's are just numbers we don't currently know, right? That's all a letter is in an equation, an x or a y or something like that. It's just a letter we don't currently know. And so you cannot, so whatever rules are true for numbers are same thing for letters. So what's the point? Let me write it up here. You cannot cancel added, subtracted items. Only cancel multiplied items. That goes for, I call them items, letters or numbers, either one, right? We can just see it simply, it's simply true. Math just follows the truth. That's what I like about math. It just simply goes where the truth goes. And so 8 plus 2 is really 10 over 2 is 5. So it's wrong. You can see it's wrong to cancel the 2's because then it would suddenly become 8. That's crazy. That's wrong. Whereas if they're multiplied, it's really 16 over 2, which is 8. Is it okay to cancel the 2's? Yeah, it's still 8. It's the correct answer. So it's okay to do. So it's okay. You can only cancel multiplied items. You cannot cancel add, subtract items. So getting back here, I can't go 2 into 10 like that because that's a subtracted item. Well, then what are we going to do? And let me put a note to help. If you had add, subtract items, all right, you can't cancel them. Instead, factor. Instead, factor. What do I mean factor? Take this on the bottom here and you factor. Factor the denominator. Okay. So what will the bottom become? You can take out a 2, right? With the 1 parenthesis, right? 2 goes into 8 and 2, and that leaves 4 minus x, right? Excuse me. Excuse me again. Okay, so can you tell that this 2 will go boom and boom, won't it? And go right back to 8 minus 2x, right? So I factored out a 2. That's why we spent all of chapter 7 learning to be really good factorers. because now 2 times 4 is 8 and 2 times x is 2x. So that's okay. No, why do we say instead factor? Well, and the top is still 10. Now this 2 is not added, subtracted. It's a multiplied item, and I can cancel it. You get it? Now we can cancel the 2. So now I'm going to go 2 into 10 5 times. So the final answer is 5 over, 5 over 4 minus x. And you don't need the parentheses on the bottom anymore. It's okay if you put them in. You just don't need them because there's nothing to separate it from anymore. The 2 that was down there is gone. So does everybody see what happened? I cannot cancel the 2 into 10 because it was subtracted. You cannot cancel added, subtracted items, only multiplied items. So then I factored the bottom. That makes it multiplied. That's what factoring is all about. You're starting to see why we did a whole chapter on factoring, why we care so much about factoring, because factoring lets us do things. So when I write the bottom as factored, meaning things multiplied, right? That 2 could multiply, distribute, and go back. Now I can cancel that 2 because now he's a multiplied item, not an added, subtracted item, right? I can factor and then I can cancel because he's multiplied. Cancel, cancel, multiplied item, right? All right, so now that you got that, let's try that on the second one. Okay, so how am I going to do the second one? Well, with the second one, you might be tempted to go, I'm going to go, 2 into 8, 2 is 4, x cancels x, and then 4 cancels 4. No, that's all illegal procedure. Why? Because I'm canceling subtracted items, right? You cannot cancel added and subtracted items. Instead, what do you do when you have added, subtracted items? Then instead you factor, which will make them multiplied items. So I'm going to say, okay, the top will stay the same. What's happening up there? On the bottom, 4x squared and 2x, what are you going to do? Take out a 2x, right? Because they have 2x in common. And then ask yourself, 2x times what? It's going to be a minus sign. 2x times 2x minus 1. Do you see that? 2x times 2x will go back to 4x squared. Remember the invisible 1 powers on the x's add? 2x times 2x goes back to 4x squared, and 2x times 1 goes back to 2x. 2x is what they had in common, right? 2 goes into 2 and 4, and when they both have the same letter, you take out the lower one. So 2x. Okay, now, so we factored. Now, why? Because now this 2x is no longer added, subtracted. It's a multiplied item, isn't it? So I can cancel it. I can cancel it again, just like last time. So I can go, oh. So now 2x into 8x 4 times. Well, here, let me redo that more clearly. I mean, that was right. But 2 goes into 8 4 times, and x cancels x. Same result. So what do we get there? We're going to get 4 is all that's left on the top because the x is canceled. And on the bottom, 2x minus 1. Again, you don't need the parentheses on the bottom because there's nothing to separate it from any longer. The stuff that was out front, 2x is gone. Make sense? 2 into 8 4 times, and x canceled x. And there we go. Again, now you think, what do you have right here? Can't we go 2 into 4? No. Okay, you think, yeah, but that 2 is multiplied. Yeah, it's multiplied by the x, but it's part of a subtracted element. So no, the whole 2x is subtracting with the 1. So we cannot cancel any part of the 2x into the 4. Does that make sense there? Because I know you might go, well, the 2 is a multiplied item. Well, no, it's part of a subtracted piece. And anything added, subtracted, we cannot cancel. So we're done. This is as simple as it'll get right there. You cannot cancel that 2 into 4 because he's part of a subtracted piece. All right, next one. Let's try this again. Hopefully this is making more sense now. All right here, same thing. You might go, oh yeah, I'm gonna go 7 into 21 3 times, and x cancels x, and 9 into 27 3 times. That was easy problem. No, that's all illegal. Totally illegal. Why? Because you cannot add, subtract, you cannot cancel added and subtracted items. Those are all added and subtracted items. Instead, factor. Okay, gonna factor, I guess. Let's do it. So the top doesn't factor. There's nothing going on the top. And 7 and 9 have nothing in common. What about down below, 21 and 27? Well, they have 3 in common. Huh? 3 goes into both those numbers. Take it out. And then what does that leave? 3 times 7x and 3 times 9. No surprise, it matches the top. See that? So 3 times 7x will go back to 21x, and 3 times 9 will go back to 27. Won't it? So I factored, and now, why do I care about that? Now on the bottom, it's multiplied. Now this time, the 3 is a multiplied item, and the whole 7x plus 9, like the whole package, is a multiplied item, right? It's in parentheses, which means times. So you can cancel the whole entire 7x plus 9 because the whole thing is multiplied on the bottom. That makes sense? The whole thing is a multiplied item. You can cancel entire multiplied items. On the bottom, the whole 7x plus 9 is in parentheses, which means it's multiplying the 3. You can cancel the whole multiplied item. Okay, so what does that leave? There's nothing left on the top, so that's a 1 over 3. See how there was nothing left on the top? So it's 1 over 3. Now you think, whoa, there's nothing. Shouldn't that be 0? No, that's what we've always done. Let me show you that that's not anything new. Think about if we have 2 over 6. What happens there? Well, you go 2 into 6, and it's 1/3, right? 2 goes into 6 3 times, it's 1/3. Or you could do it more formally. You're really dividing top and bottom by 2. So it's 1/3. So see how it's true? Whenever the top totally goes into the bottom, really we put a 1. Because really what's happening is you're dividing top and bottom by that denominator or by that numerator, whatever. So it leaves a 1 on the top. That is correct. That's what we really have always done. All right, last one. Same thing. So can't I just go 2 into 10 5 times? X cancels X, 7 into 35. No, totally illegal procedure. No, these are added and subtracted items. No. Only multiplied items. Okay. So what am I going to do? Well, on the bottom can't factor, right? 2x plus 7. 2 and 7 have nothing in common. But on the top, 10 and 35, they have 5 in common, don't they? Take out the 5. What does that leave? 2x plus 7. No big surprise. It matches. 5 times 2x is 10x. 5 times 7, 35. Huh? And now we can cancel the whole 2x plus 7 because the whole 2x plus 7 is a multiplied item. We can cancel multiplied items. What does that leave us with? 5 over 1, right? Because there's nothing on the bottom. So it's just 1. Now, what is 5 divided by 1? It's just 5, right? We never leave 1s on the bottom, but 1s on the top must stay. You might say, well, why didn't we just say this one's just 3? Well, you know that's not right? 1/3 of a candy bar, it's right after Halloween here, so I'm just thinking about candy. 1/3 of a candy bar is not the same as 3 candy bars. No way. So we can't do that's just wrong. And down here, but 5 divided by 1 is 5, right? Remember the bottom goes into the top. That's what a fraction means, bottom into top. 5 times 5 divided by 1 is indeed 5. So 1s in the, we never leave 1s in the bottom, in the denominator. We always just say the 5 divided by 1 is just 5, whereas 1s in the top must stay. So there we go.